So it's 9:30. Let's start. Welcome to the V6OPS session. Before we start everything, I will invite our AD Warren to say something.
Hello all. So today in Commonwealth countries, it's Remembrance Day. And so I'm asking that at 11 a.m. we take a brief pause for a minute or two, sort of as is custom in countries. I think we should always try and follow the customs wherever we are. I happen to also think it's a good one. But it's just sort of a minute or two of silence to sort of remember people who've died in conflicts. So whoever's talking at 11 a.m., sorry, we're going to interrupt your speech for a minute and we'll have a minute or two of silence. Thanks.
Thank you, Warren. So I will start with the note well. It's just a reminder to everybody that we should respect other participants. I also like to show you the agenda. So today we have a big agenda. We have one working group draft and six individual draft. And at the end, we also have the operational presentation to share IPv6 only hosting companies experience. And this is an overview of the working group status. So from a quantity perspective, our number of individual drafts are increasing. The number of working group draft and RFC or draft in last call are stable. So from a quantity perspective, we seem to be doing fine. But how do we measure our group in quality or industry impact? I think that this is a question that's worth thinking. My own personal perspective is that if our group is helping to solve certain IPv6 challenges facing the industry, then maybe we are doing a good job. And here we list the four challenges here. If you have other idea how we can generate a bigger impact in the industry or how our working group can do better, please let the chairs know. And the last thing is that we would like to call for contribution, because at the moment we are doing, some people are doing some very meaningful work. For example, Brian Carpenter is leading to a group to write a free IPv6 textbook. We believe that this is something very useful, because if the students are not educated in school, when they go to their jobs, they still don't understand IPv6. It will be difficult for them to deploy IPv6. So here I provide a link of this Brian's book. And also, you only need a GitHub account in order to contribute. So Brian really encouraged everybody to look at the link and contribute to this book. And the second thing is Nanili and Mike are collecting the IPv6 issues in enterprise. And we are doing some side meetings. On Tuesday, we have one. Many of the top IPv6 experts was there to comment and participate in the discussion. And we are really grateful for the contribution of these top experts. So we call for more people to participate and contribute on this. And also in V6OP and actually in 6-main or even in NANOC, there are certain topics that get debated again and again. So every 6 months or 12 months, the same topic will emerge, and then there will be a big discussion. So for example, this time there's DOISP deployment. We hope that after so many experts voice their opinion and do this discussion, we can collect the information from the mailing list and maybe write a summary draft, so that in the future, we don't need to debate it again. Maybe we can at least point people to the draft we believe that this is something meaningful, and we call for some volunteers to do this work. And also there are certain working group drafts that currently expired. And we also call for the existing co-authors or maybe some new contributor to discuss with the original co-authors whether to restart this working group draft. And if you can think of something else that are meaningful for our working group to do, please let me know. So this is the working group status. And the next topic on my agenda is my own working group draft. So Ron, can you run the slides for me while I present?
Okay,
So
give me a second to find the forward and back.
Or if, because I only have 2 slides, maybe I can run it myself.
Okay,
So
thank you very much.
So this is the first time this draft become a working group draft. And for those people who haven't read it yet, I would like to give a quick summary of what's in this draft. So the draft basically have 3 parts. The first part is a summary of the node issues and also the cause. I think that our contribution is mainly to summarize that of the 15 issues, no, they are basically triggered by only 3 causes. So if you deal with just the 3 causes, it will be easier than to deal with 15 issues. Plus, if in the future a new issue is discovered under certain cause, and if you already deal with the cause, then you automatically deal with future issues as well. And the second part of this draft is we summarize 13 optimization solutions that deal with the issues that we talk about. We not only summarize the solutions, we also discover that all of these solutions rely on, has one common thing, which is to do some kind of like host isolation to try to avoid the issues. And this host isolation can be, for example, P2P link isolation, or P2MP link isolation, or unique prefix per host, which basically put each host in its own subnet. We can call this the subnet isolation. And there are also the GUA isolation and proxy isolation. So we encourage you to take a look, because this is at least some new perspective. The third part of this draft is that we basically learn from the existing optimization solution and kind of extend this isolation idea for people to consider when they are planning their first hop deployment. So we basically recommend that you start from the highest level of isolation. There are certain entry requirements to that. You can consider that whether this is applicable to you or not. And if it's applicable to you, if you start with the highest degree of isolation, then you are the safest. You know, in the future, there may be, you know, certain new issue may be discovered, but it may already be taken care of. So you start with the highest level of isolation. If it's not applicable, then you move on to the kind of like a looser isolation. They have lower entry requirement, but it can also have more potential issues. And you basically go through a guideline and step by step until the last step is no isolation at all. So these cover all the scenario, because in the end you can give up all isolation and just do the back to the normal ND situation. So we believe that for people who are interested to know all the issues related to ND, this would be a good reference. It's like a one-stop reference that you can get all the information. The last slide basically summarizes the change in this version because, for example, Jane raised some comments in last IETF that certain solutions that we reviewed are experimental. So in this version, we pointed all of these out. Chongfeng mentioned that, well, the file name should not be called ND deployment because ND is a single protocol. So we changed the file name to ND consideration. Chongfeng also raised the point that if we do unique prefix per host, then each host can take a /64 or even a /56, and it seems to consume a lot of address. But the draft actually have a discussion on this, that given that at the moment that the many RIR can give you a /29 without the need for justification almost, then we really have sufficient /64 for every host. And if we do this, actually, it can avoid a lot of issues. So we also highlighted this. And there are some other comments that we incorporated in this version. So this is a quick update of the draft. Any comments? So nobody in the queue, then we move on to the next presentation then. Go ahead, Chongfei.
Okay. Xipeng, can you hear me?
Yes.
Okay, thank you. Hello, everyone. This draft is about a framework of IPv6 only underlying network in multi-domain networks. It has been presented in IETF 113 and 114, but I'd like to review it again. Next, please. Next, okay. The objective of this draft, as we all know, IPv4 as a service is a basic requirement for IPv6 only underlying networks. When IPv4 protocol is disabled, the network should not only carry native IPv6 service, but also ensure that the remaining IPv4 service running normally and does not impact on user's experience. Based on this consideration, the objective of this framework is to provide end-to-end IPv4 service delivery over multi-domain IPv6 only other networks and to improve data forwarding efficiency by eliminating unnecessary IPv4 IPv6 conversions in a scalable way. Next, please. This is a problem focus based on our experience. During the past, IETF has designed many IPv4 IPv6 transition technologies. Each have different IPv4 IPv6 conversion gateways. It can be encapsulation-based or translation-based. Some are stateful and some are stateless. Here, axolate is a general term to represent various IPv4 IPv6 gateways. The network in this figure is used as in the figure is a multi-domain networks which consists of AS1, AS2, and AS3. Each domain serves different scenarios in production network. To support IPv6 only, each AS uses corresponding transition technology. There are 6 different axolate gateways in this case. If IPv4 user is trying to access IPv4 service via IPv6 only network, the data stream needs to traverse AS1, AS2, AS3. When IPv4 packets reach the edge AS1, they are converted into IPv6 packets by axolate 1 and then converted into IPv4 packets by axolate 2 as egress. When at AS2, they are converted into IPv6 packets again and processed in the same way as AS1, and the process in AS3 is the same, except for the axolate gateways are different. From the perspective of operators, excessive accelerated gateways makes network complex and increase in the OPEX as well. Moreover, the IPv6 data path for IPv4 delivery is not end-to-end. It is accompanied by multiple discontinuous tunnels. Some people may say, if all the AS use the same transition technology, the problem can be solved, but that's not the case. No single existing technology can solve the transition problem of other scenarios. There are some existing IPv6 only for transit calls, such as that in IETF115-V6OPS-20221111-0930, which propose to use BGP next hop as a tunnel endpoint address. However, as mentioned in this IFC, in the inter-AS case, the AFBR as a remote endpoint of a software is not the BGP next hop for packets that need to be sent on the software. Those procedures do not work when the transit call consists of multi-AS. Therefore, we need a new framework which can set up end-to-end IPv6 tunnel or translation-based data paths across multi-domains in a secure and scalable way, so as to transfer IPv4 service from the ingress to the egress PE without any transition function in the middle of the data path. Next, please. So in this framework, each PE will be allocated and identified by at least one IPv6 mapping prefix. It will also have one or more associated IPv4 address block, which are extracted from the local IPv4 routing table or address pool. The mapping relationship between IPv4 address block and the IPv6 mapping prefix is called address mapping rule in this case. And address mapping rule is created by PE and provides prefix level mapping for stateless IPv4 IPv6 address conversion in each PE devices. Essentially, address mapping rule gives the direction of IPv4 service delivery in multi-domain networks. There are three major components in this framework. The first one is rule management layer, which is in charge of the mapping rules stored in local database. The second one is routing processing layer, with which the mapping rules can be propagated within across IPv6 only domains to provide IPv4 reachability information to other PEs, which may be cross domains. Actually, the exchanging of the prefix mapping for IPv6 only has happened at the access network, such as that defined in IFC 1750 in the DN64. But the exchanging of mapping prefix in transit call is still blank. Now this solution will fill the gap. A data forwarding layer supports IPv4 delivery by encapsulation or translation. With this design, when IPv4 packet reaches the edge of IPv6 only network, the ingress PE will use address mapping rule to generate corresponding IPv6 source and destination address of the new header from its original IPv4 source and destination address. The IPv6 packet generated are sent to the direct egress PE without being converted to IPv4 packets on the way. So it is end-to-end. In addition, there is no need to maintain user-related status or translation tables as the PE. So this approach is scalable. Next, please.
Chongfeng, you still have 5 slides. You may need to accelerate.
Okay. This chart is based on field trial in production networks. So far, it includes metro area network, IP backbone, and cloud data centers. Totally, there are 5 domains. Our practice shows that this framework is feasible and valuable. Moreover, it is compatible with existing IPv6 only techniques such as 464 XLATE. In this way, Net64 device and PE of multi-domain will converge, so the client-facing interface and the call-facing interface are both IPv6. IPv4 server will be delivered from user terminal to the egress PE directly. It can also naturally be extended to multi-AS network operated by different operators. So IPv6 only data paths can be spanned multiple operator networks. Next, please. We have received another comment since it was presented. On behalf of all the crossers, I express sincere thanks. Next, please. Based on the comments received, several changes have been made since IETF115. Firstly, SRv6 is removed from the requirement list based on the comments of Robonica. In particular, the framework does not specify TE techniques as mandatory. And the security consideration section was updated based on the comments from Jane. And then we also made revision to reflect the outcome of discussion with Jinrong and Edward on the limited list. Okay. Next, please. This draft is joint work of China Telecom, Cellnet, Verizon, Orange, Swisscom. The current version is 05. We think the document is ready for a call for adoption. So more comments are welcome as usual. Thank you for your attention, please. Question?
Any comments? Zheng Bin.
Okay, Zheng Bin from Huawei. In fact, this is pay attention to this draft and solution for a long time. In fact, I think it proposes a practical solution for the implementing the IPv6 only across multiple domains, and also because and this is a stateless solution and with much this scalability advantage. So I think this draft is the solution proposed and the architecture does work well. So in addition, I think this is related with also related with some of the solution in the control plane and the data plane. I think of this the architecture framework, we should go on to propose the possible this solution work with this data plane and this the control plane to make this architecture the complete. Okay.
Mr. Li Xing.
Hi, everybody. I'm also the co-author of this draft, and okay, you may know, like we are doing stateless translation of those kinds of things, and we have the solution. I mean, IETF has solutions for the prefix finding, for example, 7050 or the ND to sign the prefix or DHCP to give like RFs. So currently we are working like Cellnet and China Telecom, try to work on cross domain to pass this kind of transition information across domains. I believe this is a natural extension to the prefix discussion for the users, but this is for the peers. Thank you very much.
Thank you.
Thank you.
If there's no more comments, we will move on to the next draft. Why I cannot mix these?
Okay.
Go ahead.
So this is a couple of drafts on extension header testing. Yeah, troubleshooting. Next slide, please. So what I'm going to give you is the background of the problem and why we think topologies are important, and then the framework of how we want to proceed on this set of troubleshooting drafts. Next, please. So in the background, so we started testing this before, gosh, maybe about 6, 7 months ago. And the impetus really is there were quite a few studies showing that there were huge numbers of packet drops with extension headers. And so um, uh, in our own testing for our own extension header, um, we had found that, in fact, it all seemed to work just fine. And so then what we wanted to do was to see exactly uh, why things were not working and where things were not working. So then we decided to come up with a methodology for why we're seeing it. And so, for example, from last time we presented at the IEPG 114, we tested to what I'll call is uh, naked servers, the 1980s topology of the internet, which is you have a client, you have the internet, and you have a server. So that's what we had. We had a server, and everything just went right flat out onto the internet. There was no intervening network, but there were transit networks, of course, but no intervening set of servers, an edge to bound it. For example, behind a CDN or on a cloud network. And what we did is we said, well, we're going to try and go across multiple continents. I mean, so, we're a small nonprofit and we don't have like, zillions of dollars for this. And so we said, well, let's at least see if we can get servers through multiple continents. And a background, what we put in is we had, at this point, we had free BSD servers with a patch to the kernel so that they would send out an extension header with every single packet. Because what we wanted to test was real data. You can craft packets, but we felt that it's much safer and much more assurance if you can do like an actual application traffic, because then you don't have to worry about, is your packet being seen as a SYN flood attack, DOS attack, anything like that. So what we did is we sent large FTPs, and you can see we sent them from Toronto to Warsaw to Seattle, Frankfurt, everywhere we sent this huge FTP, it all worked. Next, please. So why are we seeing different results? Is it a difference in topology? Is it because we have a standalone server? Is it the type of the size? There's a lot of different reasons that might be. Or is it something else? Next, please. So what we wanted to do was develop a clear set of methodologies to say, okay, look, if you're in this topology, these might be your issues if you're not seeing uh, extension headers. For example, it could be completely unrelated to the presence of an extension header. For example, we found that for certain CDNs, IPv6 itself is disabled on the other side of the CDN. So it should be no surprise that if IPv6 itself is not supported, well then quite likely EH also is not going to be supported. Next, please. So these are the topologies we looked at. And in the next draft, I will talk in particular about what I call the naked topology, client, internet, server. That's the simplest, easiest to understand. And then, so let's start with that. The CDN topology can be quite interesting because you have to then, and we tested this by moving our own FreeBSD server which sends extension headers. We moved our own server behind the CDN so we could control it. We could take packet traces over there and on the other side. And I am happy to share the packet traces with anybody who would like them so you can see for yourself. And I can point you to the documentation of the various CDN servers if you would wish to try this yourself. We're also trying the cloud provider scenario next. Next, please. So this is the simplest topology. What happens, and again, in some ways, sometimes when we're at the IETF, I feel like this is the topology that we are all talking about. Whereas in reality, this is quite infrequent that this is the topology that we're talking about. It is sometimes the topology we're talking of. Next. Quite often, for example, if you go to the Alexa top 1,000 or top 1 million or top whatever, to the most trafficked websites, they are behind at a minimum one CDN, possibly multiple. If, for example, if you're a video streaming company, you may have an actual CDN presence. You may be also behind a CDN that your ISP provides. You may have a contract with them. So the topology becomes quite important because I will talk about this more next time when we talk about CDNs. But spoiler alert, what we have found is that quite often, if packets are not dropped outright by the CDN cache server, the EH is not passed all the way through. So again, this is quite interesting. Next, please. With cloud providers, it becomes, again, quite an interesting topology and set of experiences. Our anecdotal experience right now with putting our extension header server behind one particular cloud provider is that when you're completely standalone on the internet, everything works fine. The minute you move behind the cloud provider, again, it stops working. And let me tell you, we have two CDN providers who are working very closely with us to try to fix this situation. And the first cloud provider that we have tested with, they also have said they will work very closely with us to find out exactly where in their network things might be done. Because again, the conversations with them were, we did not realize we were doing this. So that is actually quite interesting that people are not necessarily aware that they're even doing this. So this is good, and I think bodes well for the future. Next, please. So this is our plan. We will have a set of drafts. The first three have to do with topology, and I am sure that we will find problems and during each of these. And let me tell you is, I take what Fred Baker told me long time ago, hello Fred, is that the purpose of the IETF is not to generate documents, but it is to solve problems on the internet. And somehow I have drunk his Kool-Aid, and I hope we can solve some of these problems. And again, that once we've done the topology ones, we will then move to particular pieces of equipment, because just at the hackathon in IETF 114, we found a router bug preventing transmission. So this is why we want to go very slowly and methodically and go through all the potential topologies and all the potential kinds of equipment, because we really feel that extension headers are a very useful part of IPv6, and I hope we will be able to deploy them after we fix some of these problems. Next, please. Okay, so thank you so much. Any questions, thoughts?
Hello, Nalini. Jan Linkova. Just very, very stupid question. My brain is not working. How is the troubleshooting packets with packet drop with extension header fundamentally different from troubleshooting any other packet drop you might see between source and the destination? I think the methodology will be more or less the same. I need to find where it's dropped and look in the device which is dropping it. So I'm just not sure of what is so different that we need to focus on it specifically instead of providing maybe general guidance to operators how to troubleshoot stuff.
That's a very interesting question, Jen. Very interesting. I think, no, very, very interesting, because sometimes, in fact, the packet drop is because of IPv6 itself. But hang on one second. But I think the difference is that in today's networks, there's a specific, you have to go out of your way to send extension headers and to send them at different sizes and different kinds. And so I think that is the difference. And right now, what we have been doing is sending just our own PDM destination options, because that is what we have as a real extension header. We are redoing our methodology so that we have we've implemented our stack in eBPF, which can send different kinds of extension headers and different sizes and so forth. So I think that's where we will add on. Do you see what I mean?
Yeah, in this case, I think what would be very, very useful addition to your draft is to provide guidance how exactly set those headers, right? Because people who would need the guidance on how to troubleshoot network probably have no slightest idea how to insert a random field in a random IP packet, right? Maybe some links to implementations and so on would be useful.
No, very, very good point, Jen. Yeah. Yeah. Any other thoughts? Or Suresh?
Thanks, Nalini. So I'm not sure exactly how you're doing it, but I do have an answer for Jen, so I'll just run it by you, see what you think, okay?
Great.
So what we can do is probably do 2 tests in parallel, one for just IPv6 packet without the headers and one with headers, right, at the same time, and then collect the statistics and then have a null hypothesis of it doesn't make a difference. And if you get a p-value that's smaller, then we do it. I think Anna is here, so maybe she's doing some tests too. So if she can confirm that is it, then it makes sense to me. Thanks.
No, Suresh, you are so right. That actually is exactly in the draft, and that actually is exactly what we did. But I think her point was a little bit different. Is that in some ways it is true that in either case it could be a firewall setting, it could be the topology, and so on. But after that, the next step is what you say, and that is actually in our draft too. And that is what we did. Is we said yes, it passes without the extension header. Now let's see if the problem is extension header itself. No, very true. Thanks, Suresh.
Go.
Gori Fairhurst. Wow, this is high. So what is your intention with the recommendations that come out of this? Because I see 2 different pieces here. I see if we're going to deploy and operate extension headers, we need ways of knowing and managing that operation and the paths that support it. But there's also guidance on how the extension headers should be implemented. and how they should be used by the endpoints, the end nodes. Is that other part sat in 6-man, or is there some overlap here?
No, yeah. I think I understood your question, Gori. Hang on a second. You know what? Will you go back? Yeah, stop right there. No. Go back to one, go up one more. Okay, yeah, a really good question. I mean, and really good point, Gori. There are two different things. Well, maybe even three. One, it's like if I am a designer of a certain protocol or whatever, and I wish to use a particular extension header, what should be done? Two, if I'm a user of said protocol, then what should be done? That's very true. And then, but really, I think there's, huh, okay, now this is kind of a morass, but there's actually 3, 4, 5, and 6, which is if I am, for example, a router vendor, or if I am a load balancer vendor, or if I'm a CDN, or if I'm a cloud provider, what should be done? And that's a very, very interesting topic you raised, Gori. And one of the things I'm kind of thinking is that's why we want to figure out some of the problems. And once we've figured out some of the problems and maybe even fix some of them, then at the very last thing, then maybe we do a BCP. And the BCP really is, I think, quite interesting because it's more, it's like what should people be doing? And for certain extension headers, what extension headers should be encrypted, what should be authenticated, what can go in the clear. And then, of course, then people bring up the issue of limited domain. Is it a limited domain? Is it not? That's why I kind of want to kick that whole can down the road quite a bit. Am I answering your question, Gori?
Maybe. I think the word BCP here, we have to separate somehow. To make this work, we need to advise operators what to do, give them tooling, help with configuration. But defining whether you do encryption or authentication sounds like a protocol mechanism to me. So we need to split apart the protocol recommendations, which I think probably belong in 6-man, from the operational considerations, which are equally important, but tell you how to configure, how to use, how to test, how to know it's working. And I think we have to clearly separate these out, or we'll end for some really big morass as we start to make the recommendations.
No, really, really good point, Gori. And of course, for everybody, please do contact. We have a pretty big team helping and working with us already. And anybody that wants to, work on this, especially people who have commented at the mic, such as Gori, if you got ideas, yeah, great, perfect. Okay.
So we should move on to the next.
Yeah. Okay, so this one then, now we'll start getting down to actually what methodology is. Okay, so this is what I call the naked or standalone server. This is Mr. 1980s topology. Next, please. So as I said, we've got a number of different topologies. Let's do the easiest one first. Okay, next, please. Hello. Yeah. So this is, as I say, slightly joking, I suppose, about 1980s topology. So we have the client, you have the internet with multiple transit networks, whatever, and a server. And so let's just do that. So then we've got that. And in our case, our server was enabled. And again, there are multiple ways to do this. And what Jen said was very interesting. And we have to think whether to make our code, which is a work in progress, to be available to others to test with. I have to think. Okay, but that's kind of the topology. Next, please. So that's the question, really, is like, how are you going to be able to send EHs? There's a bunch of different ways. As I say, I'm kind of a bigot on the send it with real data because I feel like, I mean, there's some awful smart people who know how to craft packets perfectly and can send them so that it's not seen by anybody as a SYN flood attack or a DOS attack and stuff. I want to keep it simple for myself. I'm like, okay, I'm just going to send an FTP. I know what it is. I'm going to do a curl. I know what it is. It's doing a real session. I don't have to worry about sequence numbers, any of that. And so then I'll do that. So, but you have to make that decision. How are you going to do this? How are you going to, that's a decision point. There's lots of packages that you can craft extension headers with, but how are you going to add them, and what's going to be the content of it? And then of course, what's the rate of sending and sampling? Because, I mean, as I say, if you send like 20 TCP SYN packets, and you're not doing if you've crafted it and you're not doing the entire SYNAX sequence, then you could be falling into SYN flood attack protection. So what you're testing is something entirely different from what you think you're testing, or even hitting a performance enhancing proxy or who knows what, which is responding to you. So again, I want to keep my simple brain simple. So I like actual data, but you have to make these decisions. Okay, so next. So then what we did is the first thing, which is the way we're doing it, which is that we have a test server enabled to send EH with every packet. And of course, we can turn that on and off, because the first thing we do is we send it off. So then if the packet is getting through at all. And if the packet's not getting through at all without the EH, well then, I mean, whatever, right? Or if it's not getting through in IPv6, well then, okay, I mean, right. But this is what we did. We had a test server, and now it's an Ubuntu server with eBPF sending EH with every packet. And then we put up, I believe we put up Apache. And we put up a huge old index.html, so that in our case, not only does it send back the DOH extension header, but it fragments. And so we got fragment headers coming back. And then the most important thing in my mind is taking a packet trace on both sides at the same time. That's why you want to have control, because if you don't know because if you're sending one thing, you want to make sure what you sent and what you received is the same thing. Okay, so next, please. So this is what we did, so what we did is just we configured it first not to send extension headers, did the thing, and then we did an HTTP curl to see if that got through, and then go ahead and sent an EH. And you may also want to send to just the IP address and not a DNS name to eliminate that part. And then you can, of course, elaborate, send DNS names, whatever. Next. Yeah. And then come back and send it with EH, do the same thing, do an HT. That's what we did. As I said, it's a pretty simple thing to follow. Next, please. So then it's normal problem diagnosis. Which packets are you not getting? Are you not getting them with EH, without EH? What? But you've got traces on both sides, so you can compare. Next. So in the next thing, again, I think we need to discuss how to craft packets, and do it if you're using a crafting methodology, because then you probably can't do a curl. But then, so we'll do some recommendations. I'm tentatively thinking send a few TCP SYN packets, and see what you get back. We've tried crafting UDP packets, ICMP packets too, but I think probably sending just a few TCP SYN is the way to go. And then we will add more discussion of troubleshooting, where to look at. The problem with more troubleshooting is that if it works without um, that's one thing. If it works, then it stops working with that becomes problematic. That may need to wait for some of the other drafts, because then you need to think. You can test some things fairly easily, like are you dropping it right at your source or not? But some of the other things, if it is indeed going behind, if it's in a transit network and so on, or if it's at some kind of router, uh, then, as I say, as we get down the road on this, we'll have more guidance at that part. So some of this will be limited guidance at this point, but as the other drafts come along, then we'll have more discussion there. Okay, anything else? Yep. So that's it. That's it for this draft. And we'll be working on the CDN and cloud provider drafts as they come along. Any thoughts, questions? Or everybody got their thoughts and questions with the last draft? Yep. Okay. Oh, somebody has that in queue.
Anton?
Hello, Anton Franco, Huawei. You mentioned in the test that you would send TCP SYN packets. In your testing, are you willing to go through the whole SYN-SYN-ACK sequence? Because I think that if you just send TCP SYNs to probe, you will be blacklisted by SYN flood prevention mechanisms.
No, I totally hear you. I totally hear you. But see, that's why I like to have the application send. It gets tricky when you're crafting packets to do a SYN-ACK sequence, but I totally hear you. It's a good point. Let me think how I can craft a sequence of packets. Yeah, no, totally good. Yeah.
Usually, people that were testing MPTCP were injecting things at the socket level in Linux by overloading the memory space, socket options. So this is something that you can do aside the application. So you can load socket options aside the application and inject parameters that the socket is taking into account to craft the packet. So maybe this is a way you want to do for your testing.
Yeah, let me talk to you offline and get some hints from you. Thank you. That's a great comment.
Hey, did you see any packet drops related to MTU issues, and did you distinguish this packet drops from?
Yeah, no, okay. So in our testing with what I'll call the naked servers, we saw tons of fragmentation, and we did not see packet drops due to MTU issues. We again, this was limited testing that we did because there was a sad story with the FreeBSD. We had an old kernel that we couldn't get upgraded and couldn't register, so we were rewriting the code in eBPF. That is something that super concerns me, is MTU drops, because right now what happened is these servers had a big old interface. It had a huge interface, which is actually good because then we saw fragmentation. But if we go from a small interface or something like that and we start doing source fragmentation, yeah, we have to see about MTU issues. Very good point. We haven't gotten there yet. In this bare set of testing, we didn't see it.
Hi.
Hi,
Thank you
Anna.
very much for the work you're doing. So just to let you know, we have a tool called Pathfinder at the University of Aberdeen. This tool can already craft whatever packet you may want to send and can do SYN, not just the SYN, a complete handshake test already.
Great. So let's talk, and then maybe we can use your tool and do the methodology for the how to do crafted packets. We talk offline. Yeah, that's perfect because as I say, it's we concentrate on the real application, but I know you guys are doing some great work, and so it will be very good to collaborate. Yeah, thank you, Anna.
Thanks.
Chongfeng. Chongfeng, you want to say something? Chongfeng? If not, then we move on.
No? Yeah, then I don't have anything. I guess the question would be, then it's a question for the chairs and the group is this work that we want to take on, or maybe after it matures, but at some point, I suppose we have to make that decision.
Okay.
Yeah. Okay, anything else? Okay, then thank you so much.
The next one is from Gaba.
Hello,
Gaba,
can you hear me?
Now, yes.
Okay, thank you. So in my draft, I just accumulate some test results, which I hope can help the network operators to find the right IP version for the service technology for their networks. And could you go to the next slide, please? Thank you. So currently we tested 464XLAT and MAPT regarding their scalability. And we had the privilege that we could use the same implementation for both technologies. So Joule was recommended a few IETFs ago, and it implements currently both 464XLAT and MAPT. So we could test both technologies with the same implementation, just to avoid the problem that different implementers can do better or worse job. So the testing method was that we used the customer edge and the provider edge devices together and benchmark them together. And we used DNS traffic for testing just because we had a DNS testing tool which we used for testing, sending packets and receiving back the packets. Could you go to the next slide, please? Thank you. So this is the measurement setup. It was used for both technologies. And before those technologies, we also tested them as just two bare routers were there just to test the performance of the system. So on the bottom left corner, you can see IP version for client running the DNS 64+ bus testing program. And the bottom right corner, you can see other IP version 4 server running the knot DNS. It was just used to answer the queries, and it has high enough performance. Without these CLAT and PLAT, when we just tested them with routers, we achieved 2 million packets per second. So it was way more than enough to test the technologies. So on the top left corner, you can see the CLAT, and the top right corner, you can see the PLAT of 464XLAT, and they were connected by 10 gigabit links using VLANs. Could you go to the next slide, please? Thank you. So you can see very little change. This is the test setup for MAPT. On the top left corner and top right corner, you can see the CE and BR devices of the MAPT technology, and we had all the necessary settings. So this is the test networks for our test. And could you go to the next slide? Thank you. So we tested the performance of the system regarding how it scales up with the number of CPU cores. So in both devices, the customer edge and provider edge devices, we increased the number of active CPU cores from 1 by doubling their number up to 16. And we used the binary search to find the highest rate at which nearly all the queries were resolved within timeout time. We allowed 0.01% packet loss. And here are the parameters just to have everything here. The PowerShell servers, and we use Debian Linux 10 and Joule 4.2. It was just a release candidate because that time it was not fully released, but we had to use the same version for both technologies to be fair with them. Could you go to the next slide? Thank you. So here are the results for 464XLAT. Here you see the number of active CPU cores, both in the CLAT and PLAT. And here the results. Of course, the most interesting things are the medians, because we executed the test for 10 times and calculated the medians. And of course, we also added minimum maximum here to show that the results were quite consistent. So there are practically no significant difference between minimum and maximum. And you can see that there's a certain scalability. So the 2-core results are 43% higher than the 1-core results, and the 4-core results are 79% higher than 2-core results, and still there's some increase at the 8-core results, about 10%, and about 4% when we switch from 4 cores to 16. But here the law of diminishing returns, that even if we double the number of CPU cores, it doesn't scale up well above 4 cores. Yeah, you can see some strange things. That's why it was just 43% at 2 cores and then 79% at 4 cores. The explanation is very simple. We use the CPU, which had a kind of NUMA architecture, that the even number of CPU cores, that is 2, so of course 0, 2, 4, 6 belong to NUMA node 0, and the odd number of cores 1, 3, 5, etc. belong to NUMA node 1. And from one core to 2 core, when we changed, we became to have a NUMA inhomogeneous system. And then after that, it was always NUMA inhomogeneous, so there's no such problem. Could you go to the next slide, please? Thank you. And you can see that the same thing also happened with MAPT. The increase from 2 cores to 4 cores is higher than for 1 core to 2 cores, but the increase is always much higher than with 464XLAT. So it shows a much better scale up, much better scalability. Even there is 42% increase when we use 16 cores instead of 8 cores. So we can say that, as expected, MAPT scale up better than 464XLAT. Could you go to the next slide? Yes, here you can see graphically. It is also true that MAPT started with somewhat lower single core result, but then it has overtaken and surpassed the performance of 464XLAT. So MAPT showed much better scale up than 464XLAT. Could you go to the next slide? Yes, that's it. So here our results were published in a paper. This is an open access paper. So if you're interested in the details, you can check our measurements. And now I have the question, if you find these things interesting or useful as network operators. And yeah, I can see that Eric is in the queue. Thank you.
So thank you. Interesting. Just a questions. Were all those DNS queries used to generate traffic, we're always using the same source port?
Sorry?
The source port, I mean, my understanding is that you were using a DNS traffic, right, for generate the load.
Yes.
Were all those queries coming from the SAS UDP ports?
The queries came from different UDP ports. Of course, the queries were going all to UDP port 53, but we used different source ports because we wanted to use RSS, receive side scaling. So we used, okay, the details. We used 16 cores to send queries and other 16 cores to receive the replies at the client, at the tester. And as far as I remember, 100 different source port numbers were used per sending cores. So altogether, 1,600 different source port numbers were used. It was the number because of MAP-T. So you know that MAP-T limits the source port numbers, and we wanted to be below 2,000. So this is why we used only 1,600 different source port numbers.
Okay, I was wondering because I would have expected if you get a huge variety of source ports, this could have maybe an impact on the performance as well. Just wondering.
We used multiple source port numbers to enable RSS to share the interrupts between the CPU cores of the servers, but it wasn't enough. So they were more or less equally shared. So it's enough to distribute the interrupts. So if we used much more source port numbers, then we would have exhausted the port number limit, port number set of the CE device of MAP-T. So we couldn't use more port numbers.
I understand the limitation for MAP-T, of course. Anyway, thank you, Gabor. Interesting.
Thank you.
Nick.
I just have a comment. One of the questions that I get asked quite frequently when working on some of the V6 only projects that I'm on is the scalability issues. So the more data that we have on different platforms that are available, I think the better off we'll be. So I just wanted to say thank you for putting the time and effort into testing these things and sharing your results.
Thank you very much for your feedback. We plan to add some more results later on. We're still working on some more measurements.
If no more questions, then we move on to Momoka's presentation.
I'll just hold this. Hello, Momoka from the WIDE project. Today, I want to talk about IPv6 only iterative resolvers utilizing the NAT64. And I submitted this draft because I had a niche problem and I wanted a niche solution and I wanted to document it. And today I want to talk about this and ask you if you think this is worth documenting or if it's just rubbish. So next slide, please. So motivation. The motivation of me writing this draft is that I wanted to have an IPv6 only iterative resolver, but it's unusable. IPv6 only iterative resolvers are unusable. This is because there are IPv4 only authoritative servers, and IPv6 only servers cannot talk to IPv4 only authoritative servers. All other applications can use DNS64, but resolvers can't use DNS64 because it's the resolver. It won't make sense. And clarification, by IPv6 only, right now I mean like it only has an IPv6 address. Okay, next slide, please. So this is like a picture of how resolving with an IPv6 only iterative resolver can fail. So the root server is dual stack, the next authoritative server might be dual stack, but the next server, the authoritative server gives me the next authoritative server to ask, but that server only has an A record, so the iterative resolver can't access the last authoritative server because the last authoritative server only has an A record and it doesn't have a CRUD A record. So this is how it can fail. Next slide, please. So this is a reference to BCP 91 OSC 3901, and in section 4, it talks about how we need to preserve namespace continuity. And I'm gonna read this out loud. So first, it says every recursive name server should be either IPv4 only or draft stack. And for the authoritative server sites, it says every DNS zone should be served by at least one IPv4 reachable authoritative name server. This makes sense because we need namespace continuity because we don't want to not be able to resolve zones. That would be sad. But we also want IPv6 only iterative service because that would be fun. So next slide, please. So my proposal is that, well, not my proposal, I'm just trying to document this. But what I want to document is that we can fulfill the spirit of BCP 91 that I just showed with an IPv6 only resolver by doing the IPv4 to IPv6 translation inside, inside the iterative resolver and making it quote unquote dual stack. So like we can do the IPv4 to IPv6 translation in the application, the resolver, and just like translate it. So next slide, please. So how it works. So first, if the resolver only finds an A record for an authoritative server, the resolver will perform address synthesis to the IPv4 address. That was wrong. And make it IPv6. This is done by applying the pref64 to the IPv4 address to construct IPv computed IPv6 address as defined in RFC 6052. Or maybe I should have coded a different RFC that I just forgot the number of, but okay. So how to obtain the pref64 of the NAT64? So there's two ways to get pref64. One is just use static configuration, or the other is to use a discovery mechanism. And there's a lot of discovery mechanisms, but the port control protocol or router advertisements can be used for this. And using, there's other mechanisms like using the mechanisms described in RFC 7050 using IPv4-alpha, or another draft, V6OPS, not 64 SRV. But I don't think these two can work because these two need a DNS64 or a resolver to work. And we don't want to rely on a resolver because we want an iterative resolver. So this is how it works. It's very simple. It's only combining, well, it's not even combining, it's just like old techniques. We're just doing it inside the resolver. Next slide, please. So considerations. So I think all of you thinking, why not just use a CLAT? Because that will solve the problem and we don't have to do this in the application layer. That is true. That is certainly true. But most applications can reach IPv4 internet via DNS64, not the 64. And an iterative resolver is theoretically the only application that has to use, I forgot the name, IPv addresses and not domain names. And, oh yeah, an iterative server is the only application that cannot utilize DNS64. And I thought using CLAT may hinder the use of native IPv6 on the machine, and CLAT forces keeping IPv4 support. So I think there may be people who disagree, but these are the reasons I brought up. Next slide, please. Do I have any slides left? Oh yeah, so implementations. Not yet merged, but so popular DNS softwares are implementing, or maybe will implement these features. There are PRs for it. For bind, Mark Andrews has his work, and for unbound, David Equi has his works. So, so I haven't done any work on this like coding thing, but I thought it would be nice to have all of this work documented as an informational RFC. So that's why I'm here. So I want to ask you people if you think this is worth documenting as an informational draft or not. So thank you.
Rio.
Hi, Rio from University of Glasgow. Thank you very much for the talk. I think right now, I think DNS is one of the tricky part of moving on to V6 only. And I think one of the tricky thing about moving to V6 is, once again, if you leave any of the V4 compatible bit or forced to keep it, then people won't be forced to move on, I think. So thank you very much for your work. And I think it should just be, should go ahead as an informational. I think it is a very useful thing to document and keep in the RFC. Thank you.
Thank you.
If no, Mark?
I'm very much in two minds about this. That merge request has been sitting around for 3 years now. If you go IPv6, if a site is going to go IPv6 only, it has to make a decision about whether it is going to, what IPv4 as a service it is going to use. And DNS6.4 is a lousy service. Really, 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 really lousy. Worrying about a node having a stub IPv4 service, so it can do CLAT, so it can run a CLAT or similar. Or we've got plenty of IPv4 as a services. They can all run down to the node without applications having to do crap like this. I wrote the crap in that commit. We have too many IPv4 as a services at the moment, and assuming that DNS6.4 is the one that people are going to be used is also very much up there. It's something that we really should be trying to stop having to do more and more and more fixes for NAT6.4, DNS6.4. And this is, we keep finding more and more things that DNS6.4 doesn't work with. We knew it didn't work with when it was put up in Behave. It was promised to be a short-lived solution. It is now plus 10 years. That is not short-lived. That's just my view. Okay?
Okay. So I can't object to that. I can't say anything to that, but as a person who like uses these mechanisms, using DNS64 and NAT64 is the easiest for people to use because I just need to set up a DNS64. I don't need to set up CLATs to the end hosts. So like it's very easy to just set up a DNS64. So I think that's why people still use DNS64. And if people still using it, I thought I might, because this draft isn't going to make people use DNS64 more. It's not going to increase the number of people using DNS64. It's just going to increase the people creating iterative resolver inside a DNS64, not 64 environment. So yeah, that's my response.
David.
David Lamparter. I would like to note, especially in response to Mark, that this doesn't really have a dependency or like there's no DNS64 inherently in this. So even if I have an IPv6 only network and I don't do NAT64 for my applications, this can help me achieve IPv6 only connectivity to some domain that happens to only have v4 authoritative name service. So I may end up having to use this just to get native v6 working because the domains aren't updating, and I don't even have DNS64 really. I just have this wait for my resolver to reach v4 only domains in the internet.
Can I come back with this, David? This is a DNS64 only solution, really, because if you have deployed 464xlat properly, you do not need this. If you have deployed DSLite properly, you do not need this. If you have deployed MAPT properly, you do not need this. I can go through the list of all the other IPv6 as a service mechanisms.
I don't want to deploy any of those.
Well, then you can also forward the queries, selectively forward IPv4 queries for IPv4 services to a service the other side of the IPv6 only link. Now, this service requires you to have a NAT64, so you've implicitly deployed either DNS64, NAT64, 464xlat, or MAPT to be in this position to begin with.
Mark, may I suggest you take the issue to the mailing list? I would like to let Lorenzo speak and then give Jane a few minutes to talk about her draft.
Lorenzo Colletti, sort of agreeing with David here. I think deploying a NAT64 is really, really, really easy. You put it in the network, you point 64FF9B at it, and you're done, right? So this is also really easy, right? If you have some code in the DNS in the recursive, it works. Deploying IPv4 as a service is kind of more difficult. You need to like deal with IPv4. If you have a server like Linux that doesn't do CLAT, then it's kind of annoying, right? You need to set up IPv4 DHCP servers or whatever other like, you know, annoying stuff that's, you know, not well integrated with distros today. So this is sort of a much lower cost option. I can see why we don't want to support, you know, NAT64 with lots of hacks. And, you know, these two implementations may decide to reject these pull requests because it's like, you know, too much complexity. But I do see a niche for this. It's, you know, it's just easy and not super harmful. So, yeah.
So we will stop here and move on to James.
Hello. Yeah. Only here, only today, 2 drafts for the price of 1. Next slide, please. So you might have seen the first draft on the list. So what's the problem here? First of all, before people start worrying about Slack versus DHCP discussion, it has nothing to do. We're not talking about how hosts get addresses, where addresses coming from. Let's just look in the normal operating system like your MacBooks here on this network. It most likely will have at least 3 addresses. If you happen to be on V6 only network, it might get 4 addresses, link local, privacy stable, and 1 for 464XLAT. And then if you need to renumber a network, it might, or you have multi-home stuff, it might actually be 7 of them, right? So stable privacy 464XLAT, all global addresses will be like doubled. Also, Chrome OS, for example, because it's running virtual machines inside, it requires between like 7 and 9 addresses currently. And it's not actually too much, right? And by the way, yesterday in PayEnergy, it was some transport people talking about their research and suggestions and thoughts about how multiple addresses would be very like interesting, different, how they could make our life in V6 world different from V4. Also, we already published an RFC, which was explicitly not recommending to limit number of V6 addresses per host. So next slide, please. Well, meantime, obviously not everyone read that RFC because some layer 2 devices, which are trying to be way too smart, do put some hard-coded limits into number of IPv6 addresses per MAC. Mostly it's devices doing SAVI or NDP proxy. And the problem is limit is there. The limit is hard-coded. And you have no idea when that limit got reached because it just quietly start dropping some addresses, not actually necessarily the unused ones. In some cases, it's just another address. I see new one, I cannot install it, I drop it on the floor. So troubleshooting becomes very like entertaining. So, and when you talk to those vendors, they're like, oh, really? You need more? Oh, okay, we can give you more. So which normally indicates they just had no idea what the limit should be, so they just picked up a reasonable number. So I was thinking some guidance might be needed. Next slide, please. So problem number 1, we have hard-coded number. So let's raise it. The draft currently saying 20. I'm not like, it was just a number taken from 7934, but I guess we can talk about what number should be reasonable. It should be definitely more than 7. And if it's too high for you, too low for you, I think it should be configurable. I think it's a reasonable demand. Well, and as an operator, I would love to know when that happens, so I don't spend time getting packet captures from 5 different places in the network. It would be nice to get a syslog message or any telemetry error saying, hello, this is a problem. And probably it would be nice if there are some attempts to drop not the most recently seen address, but one which might not be in use for a while. Next slide, please. So it's all tactical fixes. And you might see in the list that a lot of people made quite reasonable comments that increased number of addresses might cause some scalability issues on a network. And I was thinking, yeah, maybe actually we need to do something about that and make everyone happy. Maybe we can keep an almost unlimited number of addresses per host without putting any scalability stress on the devices. So last night, I submitted a draft which might talk about long-term solution, which basically saying, let's do /64 per host, but not an array, because I don't know how many implementations on the router can do that, but let's use existing mechanisms which called prefix delegation. So your host could request /64, and that means your network infrastructure will get just one route pointing to link local address. So it basically, it will scale to number of hosts, not number of addresses. It will give you the thing which a lot of people wanted, an ability to say which device was using which address. The whole /64 is your device. And it also has some fate sharing because either all addresses work or none of them. So yeah, please check the second draft as well. It's a very early draft, a lot of like sections saying we don't know exactly how to do this, we just have some high level ideas. And the comments are appreciated. I think that's all.
Okay, so it's 11 o'clock. Do we want to do the 2 minutes?
So thanks, Jen. I think the problem you have is like, really a valid problem to solve. And the 20 number, I'm not sure. Like there's some hardware limitations on some of the routers. I think we need to figure it out. And generally, I'm supportive of this work, right? But I think maybe there's other mechanisms needed. We can probably have an offline chat about it, but something to indicate like failure, right? Like that this is happening. Whatever number you increase it to 20, 200, whatever, I think somebody might hit that issue in the future. So I think we probably need a failover mechanism for that. So thanks.
Do we want to do the 2 minutes? Okay, we are back. Suresh, you won't? Okay, go ahead.
Yeah, I think I wanted to finish by 11, so I was done. So Warren, did you want to add anything to that same thing or? No, I just said like we need a protocol mechanism to signal this failure, like in addition to this. So something probably in 6-man. So okay, I'll just like do a straw man, right? The straw man would be some ICMP message, V6 message, which says like, no, I ran out of ND cache entries for you. Like, I don't know if I come up with a message, right? I know I need to think a little bit more through like, what attack vectors this enables, but that's kind of what I was thinking, okay? Saying that you may not use this address anymore, right? I know Lorenzo is going to be pissed that a router can say that to a host, but we need to somehow say like you're past your welcome.
The problem
more
here,
like
it's
more
not
like we have a BCP that says not to do that. It's not like Lorenzo would be pissed, but we have a BCP that says don't do that.
no, Suresh, also remember it's not routers. It's not even routers. That device might not be able actually to send you anything, well, without any hacks, right? It's like layer 2, like access points, right?
No, I got it. What I'm saying is I don't like this to be a silent failure because right now it's a silent failure that like this thing, you cross your ND cache entries, whatever limit, right? And there's no indication from the router. Like, but this is not an indication to stop. It's like a router saying, I cannot do this, right? Which could be taken as like just an indication, like if you don't want to do anything. I got Lorenzo's point, right, about the BCP. So I'm fully cognizant of that, but I'm saying there's no indication from the router that this is happening. The packets are getting black holed.
So I think there are two things here. First, there is no reason of sending an alarm if it's not non-actionable, right? If device cannot use it, it just fails. So it fails anyway. That's why I'm saying we need to log this so an operator deals with this, right? Not necessary host.
Yeah.
And secondly, long-term solution should deal with that.
I got it.
Read the second draft.
Exactly. So the second draft as well, I just wanted to put in a point. The 3GPP already does it, right? Like, so I think there's an IETF recommendation to 3GPP saying for every host, give them a /64 for themselves, right? So I don't think we need to like make a big stretch from there to say like give it to everybody. So I'm sure there's like issues like implementing this on a Wi-Fi AP or something, but I think I'm 2 thumbs up for that idea. Thanks.
Ooh, Warren Kamari with no hats. So your first set of discussions draft you were talking about, I've got a little D-Link router at home. It's got the world's smallest TCAM. Apparently it can deal with like 4 addresses per host. Woohoo! Would it be compliant with your new thing? Like, if the hardware seriously cannot support?
Well, that's why, okay, I have to apologize. The draft currently say must. I think we need to say it should. So yeah, so like, yeah, if you cannot do this, yeah, it's a scalability issue, but I'm talking about like enterprise scale, large people who put like numbers like 5 there.
Okay, Eric Vink. 2 points. I mean, increasing the numbers of IPv6 addresses per MAC will present some challenges, right, regarding the multicast, notably. It all depends upon the number. But also, if it's the AP which enforces this limit, or is it the router which is behind the AP? And of course, we need to increment the numbers of IPv6 addresses per MAC address on both sides, right? Anyway, you know this as I know. Regarding this slide and using a /64 via prefix delegation, this is kind of cool, of course. It solves many problems, except the privacy one. Because if you use multiple IPv6 addresses, right, is to provide you with privacy. Once the MAC addresses disappear, right, over the internet, you use 5 or 10 different v6 addresses, we cannot say it's you. Now, if you're using a /64, we know it's you.
Actually, you don't, because how do you know if 2 addresses belongs to 64 allocated to a device or 2 different devices in my Slack network?
I can, honestly, we can guess it, right? That's... Yeah, agreed. But if everyone is doing a /64, let's say in 5 years, then you lose the benefit of privacy. That's a client issue, I do agree.
You don't know if it's the same. I'm not going to give you same /64 every time, right? You join the network, you get like 5 minutes later another one, so it's...
Oh, if you want to get PD refresh as often? Now we are hitting most probably, don't forget the HTTP stateful, right? So the HTTP server really has some fun. But anyway, interesting.
Yeah, I mean, I guess I'm an author, so I can't really say much, but I am hopeful that this will actually work, the long-term solution will actually work, and maybe finally resolve this argument that we've been having for years and years about, you know, network versus host. And like one thing that maybe is not in the draft is that you can hand this to a laptop, and you know, you can create 1 million Docker containers on it, and they can all have end-to-end connectivity, and it'll just work. And that's something that we've we can maybe sort of do that with IPv4, but they can't receive any packets, right? And if we wanted to basically give these things incoming connectivity, it really wouldn't work, because you'd like bust the NAT's like port forwarding tables, right? So this is really something that it's going to be a substantial improvement over what we can do in IPv4. And I don't think, you know, it's going to hit the same sort of host versus network tussle that we've been seeing. So I'm really hopeful that this will go somewhere. And I think we need help getting this to work. Somebody who knows DHCPD in particular and how it's implemented. For example, we were looking at some corner case where we, you know, or if you have two DHCPv6 relays on the link and you do PD on both of them, like what happens, right? Presumably both of them can snoop the reply because both of them like forward the request. But anyway, so we'd really like, you know, someone who knows DHCPv6 and PD in particular to like help us figure out how to do and what to do. So help welcome. Thank you.
Thank you. Folks, I will have to ask you to take the issue to the list because we are already 8 minutes late. So we'll move on to the last presentation from Pete.
Hi, Pete Stevens from Mythic Beasts. So 4 years ago, I came here and talked about some of our IPv6 only stuff that we've deployed to actual paying customers, and I'm back. Next one, please. So what did we do? 2014, we deployed virtual servers that only have v6. Nobody bought them because they can't talk to anything and it's not very useful. So over the next couple of years, we decided that what we were going to do was deploy an actual application that functioned and was useful and a paying customer would buy that only used v6 on the virtual server. So we added some things to the network. So you get NAT64 and DNS64, so you can talk outbound to other things, and we implemented a proxy service that automatically configures HTTP, HTTPS inbound, and a few other SSL-based protocols. And so on a VM, you can have a v4 address optionally, but you'll get a /64 of v6 space, and that's what we currently do now. Next slide, please. And the first thing we learn is dual stack is rubbish. I hate dual stack. I'd like it to go away. If you just have to configure everything twice, you have to configure your firewalls twice, you have to do your connectivity twice. So all of our management layer supports v6 for everything. So for any application where we can turn off v4, it's less configuration and less work, and we get to conserve the v4 address, which makes it cheaper. So don't do dual stack if you can possibly avoid it. Go straight to v6. Next one, please. So what doesn't work? Email. You can't do email from a v6 only server because there's a whole load of v4 only people out there. However, the large providers have fixed this. Email doesn't work from v4 either these days. So whatever, you're going to forward it through someone else, and as long as your MX relay's got v6, you give it to them and hand it over. FTP, web developers like FTP. That really doesn't work very well v6 only because you can't forward it from a v4 address. Turn it off, fine, whatever. Hadoop, there's a few other distributed things that don't work. There's more applications that assert v4 in the way they're built. So those, you have to have v4 addresses. We can't run those yet. Next, please. What doesn't work very well? Node.js is probably the biggest pain point for us. It has very strong ideas about why it wants to connect out over v4, even when the DNS server gave it a quad A address that it should be using. Docker, the whole thing is built on the assumption there's network address translation everywhere. So a whole load of the firewalling tools and stuff don't work, which is a shame because Docker is the absolute perfect use case for v6 because rather than having to implement an overlay network from one of the multiple alternative sources of overlay networks, you could just give it a v6 block and let everything talk to each other out of the box and it would all work. Snap, applications deployed in snaps on Ubuntu will frequently refuse to download themselves over v6. And basically, there's a lot of applications that will prefer v4 over v6 because v4 always works. And a bunch of those you can fix by just breaking v4 completely. If you don't give them A records back, they will eventually decide to connect over v6 and work. Next one, please. So when we did our first implementation, what did we get wrong? We did a /64 LAN for each of our data centers that had a /24 of v4 space in and gave customers a /96 of address space from it. All the block lists decided to filter on a /64. One spamming customer, your data center can't send any traffic to people who blocked you anymore. So now we give every customer a /48 if they want it, and you get a /64 per host. So each host is individually blockable by internet block lists, and renumbering this was not a great deal of fun. Next one, please. Filtering. This is probably one of the biggest pain points. When you're on a v6 only server, the whole of IPv4 appears to come from one IP address. So when you get denial of service from a bunch of v4 things, it all comes in from the same v6 address, and separating the traffic out to selectively block malicious hosts is really hard. And you can quite easily accidentally block the entirety of v4. Today, that's much less of a problem than it used to be because substantial fractions of your traffic come in over v6, and accidentally dropping half your traffic is a lot less embarrassing than dropping all of it. So, and for all the web applications, which is the majority of what we deal with, what this means is you need to pass the v4 address through using proxy protocol and then Apache filters in the Apache config rather than doing it more quickly at the firewall level on your host machine, which is a little annoying, but it kind of works. Next one, please. So we've got a proof of concept proxy implementation that takes an entire 4 billion v6 addresses. And so when it proxies the address back to you, it embeds the source v4 address in the v6 address so the traffic comes on. And then you can use your firewall because every single v4 address appears to come from a different v6 address out of the proxy, which is very much like NAT64 in reverse. We've embedded the destination port number. We're not sure if that's a good idea or not, but basically we really need to get this built into HA proxy, which is what we use for our proxy service. And then every v4 address looks like a v6 address and all of your v6 filtering tools work better. So that's coming next. More things that went badly. Large on-link prefixes don't work very well. If you give your customer a /64, they can use a different IP address for every single outgoing connection they ever make. And they do this to try and avoid other people's rate limits. And that's really painful. And even if they do it across your LAN, you know, just being scanned continuously from vast numbers of v6 addresses appearing. Similarly, when people scan your address space inbound and try and enumerate what's sat there in a /64, and you spend the entire time trying to neighbor discover who is actually using these v6 addresses, that's pretty bad. Next slide. And basically, it comes down to the fact that a /64 doesn't fit in RAM. You can't maintain a complete /64 of v6 to MAC address mappings. There's lots of exciting things you can discover in the Linux network stack about what happens when it garbage collects all of this stuff. You can stall your inbound network for tens of milliseconds, maybe even 100. And anyone in the same layer 2 domain as you can force you to neighbor discover billions of addresses, and that's really annoying. Next one, please. So, which gets back to the question of why do we do neighbor discovery or even ARP for that matter? And basically it's to turn a v4 or v6 address into a MAC address. But we've got a billing database that already knows where every address can go to in our network. And for security reasons, if we get an answer from a machine that doesn't match what our billing database thinks, we should throw it away because that's a security violation. So why do we actually do this at all? Next slide, please. So now we don't, mostly. All of our switches know all of the link local addresses of all of our v6 address blocks. Our BGP daemon running on the switch is Bird. It knows about all the v6 ranges attached to all the customers. So as soon as the link comes up, it advertises out and says, I've got this /64, you can route me traffic over here, and it hands it all to the link local address. And we don't need to do neighbor discovery. Next slide. And so essentially everything on our network is now migrating to completely layer 3. Every link is point to point. Everything is routed. We don't want to care about having multiple things on the same layer 2 segment. There is one thing, we know it's link local address, we route to it. And 2 of our 5 data centers are now basically enabled with this, and the rest are being worked around over probably the next 6 to 12 months. Next slide, please. So how are we doing? So this is infrastructure that Mythic Beast manage ourselves and customers who are on servers that we manage for them, or we provide some level of management, security updates, and so on. About a quarter of them are still v4 single stack, a little over a quarter are dual stack, and just under half are v6 single stack, which is obviously really good news. We've come a really long way. Next slide. Next one. Unfortunately, that's not quite as good as it seems. The v6 only ones are newer and typically tend to be simpler. And one of the reasons for that is because v6 addresses are free, you tend to spin up more servers because they don't have a v4 tax cost attached to them. And so you get distributed applications rather than monoliths with lots of things running on the same v4 address. So there's So, you know, a good like 25% of that V6 graph is actually one application that we just run hundreds and hundreds and hundreds of identical copies of. Whereas the V4, every one of those is a special snowflake and needs a little bit of help. Next one, please. And turning off legacy things is really hard. So we've got 3% of our V4 servers are due to go by the end of the month. This is a CentOS 5 build that we deployed in 2017 when CentOS 5 went end of life, as a 6-month migration project to move on to the newer stack that our customer was using, which finished in September 2022, an overrun of 4.5 years on a 6-month project. So turning off your V4 only things is very hard. They are going to be here for a really long time. And in sorting this talk out, I found we've actually got some of our public facing things that are still V4 only that we hadn't noticed. So I need to finish auditing and fixing all of those so they are all dual stack. Next one, please. So yeah, V4 is always going to be here. Some things are too expensive and too hard to migrate to V6. We just did a new V4 only setup on behalf of, they're not technically a bank, but basically they're a bank. It does Swift transactions. We charged them extra for V4. They were fine. They're a bank. They're never going to run out of money. If we charged them $100 a month for every V4 address they used, they would be fine with that. Next slide, please. So, which gets you into a chat from finance side. This is not financial advice. Do not take my advice on finance. Use proper, like, qualified people and whatever. When we started V6 only in 2014, we set the price of a V4 address at £2 a month because it seemed like a good number that was just enough that most people wouldn't moan about having to pay it, and the other half would get really angry and turn off V4, which was what we were aiming for. Next slide. This appears to have become relatively standard. Amazon, $3.60 a month, Azure, $260, Google, $288. It varies. Interestingly, on the access side, it's a bit cheaper. Zen Internet's 83p a month. So, but basically, yeah, you're looking pound, couple of dollars a month for a V4 address. Next slide, please. If you go and talk to someone who works in finance, they have very interesting things to say about this, because people who run pension funds buy government bonds and they get 3.5% back, whereas today you can buy an IP address on the open market for $50 and rent it for $2 a month, netting you a 48% return. So if you had $200 billion and you could buy the entire V4 space, you could solve the problem of pension funds being solvent. Which is worth thinking about. Now, obviously, IPv4 addresses have higher risk attached to them than government bonds because governments always pay their debts and everyone's going to move off V4. So, you know, you need a higher rate of return, but does it need to be 10 times as good? Would double be good enough? You know, who knows? So, yeah, that's one to think about. Next slide. And this also comes on to some thoughts. This is a fictional tier 1 ISP. Those figures are not that different from a couple of real ones. Enterprise value is the cost of buying all the shares in your ISP and paying off all of its debts. $3 billion will buy you a tier 1 ISP roughly and get you 30 million IP addresses, which works out at $100 an IP address. So half the value of that tier 1 ISP is its IPv4 space at today's prices. If you can get IPv4 addresses to $120, you could buy the entire ISP, sell the IP space, clear yourself, what, $600 million, and throw away your tier 1 ISP. Next slide. Which takes you to Wall Street, where, of course, the key plot point in the film from the 80s is Gordon the Gecko spots the pension fund has more money than it needs to pay the pensioners, buys the airline, shuts it, and steals the money. Is that going to happen to some ISPs out there? Who needs to be really scared, and at what value per IP do you need to get frightened? Next slide. My good friend Eben Upton, who made not only this t-shirt, he builds computers that cost $5 and they cost $50 to connect to the internet. Someone did point out the last time I said this that it's very hard to buy a Raspberry Pi Zero for $5 anymore due to supply constraints, to which my response is, I am prepared to bet that more Raspberry Pi Zeros will come out of the Raspberry Pi Zero factory than IPv4 addresses come out of the IPv4 address factory. So, next slide. So, we built a Raspberry Pi cloud. That's a lot of Raspberry Pi 4s in an enclosure. Those are much more expensive Raspberry Pis. They cost $35 or even $55 for some of them. So still the same cost as a V4 address, roughly. And you start racking them up and stacking them in racks. Next slide. And they start to look like this. You have some fans on the back to keep them cold and a lot of PoE switches in order to give them power and network. They have one wire to each. They all net boot. They talk to a file server. And what you can see there is right on the bottom with all the ugly wires. That's the Pi 3, the previous model that doesn't stack quite so close. All the top ones are the Pi 4s. That's 384 servers in 9U of rack space. Next slide, please. So 3U chassis, you mount 2 of them back to back, 96 Pi 4s. Each one of those is a quad-core machine with 8 gig of RAM. You've got a couple of 48-port switches. For reasons of compatibility with the Pi 3, although this might be solved in the newest firmware release in the Pi 4, it only does V4 for the first stage of NetBoot. So we give it a tiny amount of RFC 1918 space to get to the NFS file system so you can boot the thing. We can't afford to give these a V4 address each because the V4 addresses are the same price as the computers. So we thought about it and we said, right, no V4. We're just not doing it. You can't have V4. All external communication has to be V6. Next slide. We do lose some customers. These are some complaints from people who have sent us on Sport, which basically says, I'm cancelling this because it doesn't have V4, rah, 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 I don't want it, which is fine. Okay, buy a different service that costs more. Next slide, please. Biggest support query we get is lots of people go, I've got a server on the internet, I immediately need to secure it. Let's immediately configure a super secure IPv firewall. Things you can firewall, your file system. That's it. The only thing you can firewall. This does not end very well. So yeah, there's a bit of explaining that you need to implement a V6 firewall. Please don't implement a V4 one. That will not help. Next slide. So back to some of those badly behaved applications. Node.js, hosts file workaround is the easy way to do a bunch of these. You put some static entries in your host file, and then Node will not get an A record for a DNS query, so it won't know V4 is available, and that will force it to use V6, and it will connect out and go and download the bits and pieces it wants. Because basically the implementation sees it's got a RFC 19 address on the host, and V4 always works, so you should always prefer that, even in environments when it doesn't. So yeah, Node Package Manager Fastly provides dual stack for all the package downloads. You have a V6 only Raspberry Pi, and it still won't download over V6 because it wants to use V4 because it thinks that that's more reliable. Next slide. So trying to work out what to do about some of these. We thought about actually making our DNS servers not reply to A requests at all. Is possibly worth doing. There's a library called TNAT64, which basically intercepts all of your OpenSocket connections and forces them out over V6. In theory, it's not supposed to intercept ones to 127.0.0.1, but last time I tried this, I kept having problems with that. And it's really annoying if your application now can talk to all the other things it needs to talk to on the internet, but can't talk to its database server that's on the same machine. And painfully, CLAT, Tor Anderson wrote a CLAT implementation for Linux. You install it, and V4 magically works on your V6 only server, and all of your applications do not need to be educated that they're in a new network environment. I would dearly like to fix all the applications, but as a workaround, this gets you going. So maybe we need to install this by default, possibly. Next slide. So next question, I get this a lot, like this is a toy, right? No one would seriously use this for anything. So there's 25 million Raspberry Pis that are in industrial applications. Some of the companies that use Raspberry Pis in their applications have continuous integration setups where they build their software and want to test it on Raspberry Pis. Some people want to spin a load of them up on demand for various things. Distributed computing systems, like actually having real computers, not virtual ones, has advantages in research, so people do that. Next slide. And the most exciting one is Pi Wheels. This came out of the International Space Station. The International Space Station has some Raspberry Pis on it for kids to do scientific research projects. they all need numerical Python. Numerical Python is a massive C library that goes into Python, and it takes 2.5 hours to compile on a Pi, which really slows down the whole thing. So what you want to do is pre-compile it and distribute it. And that project got out of hand. Ben, who ran it, decided to pre-compile every Python module for every Python version for the Raspberry Pi and make it into a service that it just downloads binaries to speed everything up. This is done entirely in our Raspberry Pi cloud. It's all natively compiled because cross-compilation is no fun. And it does all the distribution from the Raspberry Pi cloud as well. And it all goes through our v4, v6 proxy service to all the people who don't have v6 at the end. Next slide, please. And it does north of 1 million packages a day being downloaded, right? That's a real application with a lot of end users running v6 only in a Raspberry Pi environment. So you can use this for production things. And we don't know how many other people now depend on this working in order that their continuous integration and build and everything in their offices relies on. Next slide, please. Also, we have desktop users who don't know they're running in a NAT64 environment because they just spin up a desktop in our Raspberry Pi cloud and the internet kind of works and you can go to websites and so on. So we have another set of users there. Next slide, please. Anyone heard of a thing called Mastodon? Last week, this would have been an entertaining question, but probably more hands today. Yeah, that became a thing since I wrote the slides and arriving here, so I had to add some in very quickly yesterday. It's a decentralized micro-blogging platform, like basically it's Twitter, but without a mad founder. And it's suddenly become extremely popular. And every Mastodon server, you run your own instance of Mastodon or you use someone else's instance and they federate so they all have to talk to each other. So that means suddenly we've got an application that's using thousands and thousands of servers that all need to communicate with each other. So they all need v4 addresses. Next slide. And it turns out that, again, is this a toy, a geek project? This bloke called Stephen Fry, apparently he's quite famous, he's migrated and turned off his Twitter account. So suddenly there's real users, actual departments, money's about to turn up. Next slide. So yeah, it's currently 4,000 servers. It might be 5,000 by the time this talk ends. And they all need v4 because every server has to be able to talk to every other server in order to make it work. Unless, of course, you can put it on one of our v6 only services, use our inbound proxy for v4 because it's all HTTPS, and then use DNS64, NAT64, and CLATD because it's built on Node.js, and you can't, etc. host file work around every server that gets sprung up in every 3 minutes. So, it's a bit of a pain. However, some other people, some of whom are also customers of ours, have already started submitting bug fixes to get this to work in a pure DNS64, NAT64 environment, which is nice. There are enough people running this in a v6 only environment that they're starting to submit software bug fixes, because fundamentally the people who started using this are techies and cheap. So they don't want to pay for v4 addresses if they don't have to, and fixing source code is easy. So there's some of those out there already. Next slide. So this guy called Alistair Allen, he works for Raspberry Pi in their social media team, and he said, we want to run our own Mastodon instance just for Raspberry Pi, and we want to run it on a Raspberry Pi as our production social media application for a company with 500,000 Twitter followers. Let's see how many we get on this service. That was the brief we got at 11 a.m. on Monday morning, and we went production at 10 a.m. on Wednesday, which was a little quicker than we were really aiming for. But yeah, so Raspberry Pi's production social media is sat in our Pi cloud running on a Raspberry Pi in a v6 only environment to talk to Mastodon, which is a massively exploding social media network. And no v4 is used anywhere in the whole thing directly. And we can keep spinning up more and more of these and add more Mastodon instances, and we don't need to consume any v4 addresses. All the v6 traffic goes direct. The v4 stuff gets proxied and gets slightly slower paths or possibly gets pulled around. Next slide. Yes, and the thing that comes with this is if you self-host v6 on a VM or on a Raspberry Pi, it costs less than £8 a month, which is suddenly a very significant pricing number, thanks to a little blue tick costing $8 a month. But yeah, the important point from our point is we can keep deploying these without consuming our remaining v4 space. Our ability to sell Mastodon servers is not limited by our v4 space, which is good because we can't get any more of that. And the other thing is there's a load of v4 only Mastodon out there, and we don't care. We don't need them to migrate. They can stay v4 forever if they want to, or they can migrate. It's up to them. We're not compelling other people to move, and we don't need them to move in order to enable our service. Next slide, please. This gets onto the question that I got asked at RIPE, which is how do we get more network engineers and more people trained to build applications and understand that they're working in v6 only environment. So my first thought was it'd be really nice to just have a completely simple setup where you have an image for a Raspberry Pi, you plug it into your switch, and it springs up a Wi-Fi network that is DNS64, NAT64, and you can connect to it, and hey presto, you're in a v6 only environment, and you can start testing your applications and make them work, which is very similar to what Apple did for iOS applications. The other one, of course, is rent a Raspberry Pi desktop in our cloud, and you get that by default. Some people haven't noticed. And the next training exercise is going to be build your own v6 only Mastodon server and join the Fediverse, which we've got sometime next week, an article with a tutorial on how to do that coming out. And this is what will hopefully start to drive the software people to understand that v6 is a thing, v6 only environments exist, and your software does need to work in those. Because the application side is the barrier more than the network side from where I sit. Next slide. The other thing for providers is easing dual stack. I have Pixie Boot on all of my servers, so I can recover them and reinstall them and whatever. At the moment, that all starts with v4 because Pixie Boot works with v4 reliably everywhere. I haven't really tested it properly on v6, but really I do want v6 Pixie Boot. And that means when my server turns on, I want to see its MAC address and give it a v6 address in the simplest way possible. And it's the MAC address I care about because I already know what the MAC address of the server is, and that's the thing that tells me what address it needs to get. So ultimately, I need a file with MAC address, v4 address, v6 address, and the ability to remove the v4 addresses. That's what I want going forward. Next slide, please. As mentioned, I've already removed layer 2 from all of my new network. Everything's point-to-point, which means my switches are running a DHCP4 server already. It's a very small, very simple DHCP4 server because all it says is that MAC address gets this v4 address and this netboot details, and that's the only answer it ever gives because it doesn't have to manage leases because everything's completely static. Do I need to do this for v6? Do I need to write a DHCP6 server that just says, hello, Mr. DHCP6, here's your v6 address, here's how you netboot, and just carries on. So that's the thing I would really like if someone would build me one of those. Next one. And that's it, a brief summary to what it's like trying to operate in a v6 only world when you have to deal with like customers and people with arbitrary demands. So yeah, we have a blog, we have a brand new Mastodon address, and we even have a Twitter address, which should work for at least a week. Other than that, you can drop me an email. So any questions?
Hi, David. Thanks for the talk. You said you went fully L3, so down to the host, I imagine. Are you running a BGP service or like a route reflector on each of your hosts?
Every switch is running BGP.
So to the switch, not to the host.
So we aren't running not unless the customer has their own ASN, which some of them do. So our hosts just boot as normal, and when the interface comes up, we see link discovery happen. And at that point, it's going to have a link local address, and we know what that is. So at that point, a process on the switch injects the BGP route into the local BGP server, which then floods out to the network and routing happens.
Okay, thank you.
Mr. Cleary, very interesting talk, thank you. A couple of things, the Pixie Boot thing, could you do Slack with EUI64 addresses, or do you really need DHCP? Because I mean, the nice thing about like a EUI64 address is that it's predictable and it's very similar to the MAC address. So I don't know. It depends on the implementation, I guess.
Yeah, then I've got to run a Slack service on my switches rather than DHCP. Can you do full Pixie Boot with just Slack?
I don't know. No.
Don't I need DHCP there at some point to give out DNS service and things?
The boot image, right? Yeah.
Yeah. So basically, I'm also there's a parity thing, right? I already have a whole load of people who understand how Pixie Boot v4 works, and this is not an interesting problem to solve. I just want the thing to switch on.
Yep. Couple of other questions. I tried to do the Raspberry Pi thing myself. I got Pi 4. I wanted it to sit on the side of my network and send an RA with a 96 of the NAT64 prefix, because I don't control my home gateway. So I wanted to plug in my Raspberry Pi, advertise the 96 prefix, send a separate RA with the pref64 option, so that, you know, basically clients would just see it and they would just get NAT64 on my existing Wi-Fi network, which has V6. It has native V6. I failed because the Raspberry Pi dependency of the dual package didn't work, but okay, I guess I'll try again.
Right. Yeah. I mean, it doesn't have to be that, but basically, yeah, the simplest possible way to get a NAT64 network at home for an enthusiast would be a really useful training thing to do. And the Pi advantage is there's loads of them kicking around in boxes, so people can do it for no setup fee.
Yeah, because there's some, I think I even put it on GitHub, there's some code that will send an RA with the NAT64 option. It doesn't have to be the same RA that the production network sends. You can just like have it on the side and you can send an RAO for it, right? So anyway, we can chat about that offline.
Yeah, sure.
And another question that was interesting is like it sounds like you ended up doing 64s to the VM. Is that right? Or
Yeah, 64 to the VM.
Are you worried about eventually running out of V6 space, or, you know, because customers can create a lot of VMs?
I'm not especially worried about running out of V6 space. Partly because a company I acquired ran into the V4 exhaustion very early because they sold very cheap VMs. And they future-proofed themselves, not by actually making V6 work, which would have been sensible, but by acquiring as much V6 space as they could. I think I'm sat on like a /27 of V6 space, which for a small company with 15 employees is probably enough for a bit. Yeah, I mean, ultimately I've got what, like 10 billion servers worth of V6 space, so it's not exactly a /64 per VM. It's a /64. Well, it can be, but customers can use multiple addresses from the same 64 across multiple VMs. So it's not quite as wasteful as a full 64 every time a VM gets turned on. But if a new customer turns up, their VM gets spun up and they get handed a /64. And they can have 48s on request.
Yeah, 64 per customer, you'll never run out of that, I think. But anyway, interesting, thank you.
Yeah.
Hi, you mentioned CLAT-D.
Yeah.
And you mentioned it needs to be packaged, and I can probably get that into Debian as I'm a Debian developer.
Can I buy you a drink? Thank you.
Okay, that's it.
Thank you. Yeah. To possibly accelerate that, no, yeah, if you can just turn it into a Debian package, that'd be ace, even if I can just steal it and stick it in the Mythic package repository that we use for customers before it turns up in proper Debian.
Did you open a bug on the Debian backtracker for asking for it to be packaged?
I haven't, no. I only really thought about this on Monday when I properly put it in to make Mastodon go. But yeah, turn it into a Debian package. That would be amazing. Thank you.
Please, please, please.
Yeah.
If no more questions, then we thank Pete for the excellent presentation. Thank you, folks.
Anna, pleased to meet you. Yeah. See you around, hopefully in Japan. Yes. You got it. So, you going to send me a skeleton or you want me to put up a skeleton?
Oh my God, they're 15 minutes late.
Yeah. All right. Go.